हेलो बच्चों, today I will start remainder theorem and factor theorem. That is exercise 2.3. Exercise 2.3. There is a little bit difference between remainder and factor theorem. Before going into the concept, let us understand with the help of numerical example. What is remainder? Suppose if I am dividing 12 by 3, what will happen? This will go 4 times. 3 4 ja 12, and the division is completed. There is no remainder. There is no remainder, or we can say remainder is 0, because when you will subtract 12 from 12, you will get 0. Means remainder, let us represent it by r. Remainder is 0. Let us take another number, 14. If you divide 14 by 3, what will happen? Again it will go 4 times. 3 4 ja 12, and after subtraction you will get 2. In this case remainder would be 2. By observing the remainder, you can say that whether the divisor is a factor of the dividend or not. In this case 12 can be represented as 3 into 4, means multiplication of quotient and divisor will give you the dividend. Then you can say 3 is a factor of 12 because it is divisible by 3. 12 is divisible by 3. In this case remainder is 2. Then you will say 3 is not the factor of 14 because it is not fully divisible. Or you can say remainder is not coming 0. One conclusion is you are drawing here. If remainder is 0, it does mean the divisor is a factor. If remainder is not 0, it may be any value. Or simply you can say if it is not equal to 0. If it is not equal to 0, it means not a factor. Then you are drawing a conclusion. If remainder, R stands for remainder, for the sake of simplicity, 0, then divisor is a factor. If R is not equal to 0, then divisor is not a factor. These two conditions I had done with taking the numerical example because it would be more easy. Now if you come to the algebraic expression means the polynomials which you have read in previous exercise, that is 2.1 and 2. Let us take an polynomial. When you will take a polynomial, for the sake of simplicity, I am taking x cube plus 1. X cube plus 1. And it is divided by another polynomial. You can say x plus 1. When you will divide this by x plus 1, what will happen? Let us observe. By the proper division method, x cube plus 1, you will write in the manner x plus 1 this side. Now you have to choose a value. Value means whether digit or number, letter or both, such that after multiplication you are getting the same term in both the lines. So that's why it is having x to the power 1, here x to the power 3. Two powers are less. Digit 2 is less in the power. It means you will have to multiply it by x square. When you will multiply by x square, what will happen? X square into x will give you x power 3 plus x square. X square 1 x square. Now the subtraction step, change the sign, this will be cancelled. What you are getting? Minus x square plus 1. All the things would be written but in a line in descending order. Now you will have to multiply it by negative sign because similar term is to create in the next step, down step, and x because 1x is looking here, a square is required, then 1x you will have to take x to the power 1, means minus x square minus x. Again subtraction process, plus plus, this will be cancelled, you will get x plus 1. Now this will go one time because x plus 1 is here, x plus 1 is here, plus 1, x plus 1, change the sign, minus minus, term cancelled, 0. What you are observing here, in this case also remainder is 0, means x plus 1 is a factor of this one, or you can say x plus 1 is a factor of px, you can say. Rather you write x cube plus 1 or simply px. Now what you are observing, you are saying this due to remainder has come to 0. Suppose remainder would have been any finite value except 0, then you can't say this statement. Now one thing understand more, what you have to do regarding the remainder theorem. Remainder you have come to the concept of remainder, but in the theorem this multiplication division process can be expressed as a formula, and formula I think you will recall soon, as I write here, that is the divisor is equal to dividend is equal to divisor into quotient into plus remainder. This is a formula. It means if you multiply 3 4 ja 12 and plus the remainder 2, you will get the dividend. In the same manner, this can be expressed as in the algebraic expression. Suppose your dividend is px and divisor would be any factor. Divisor can be taken as x plus or x minus a, whatever. Into quotient can be represented as qx. Q stands for quotient and qx means any expression like this algebraic, and plus remainder you can say rx, r for remainder and rx. If this remainder is coming 0, then you can say x plus 1 is a factor. If remainder is not 0, you can't say it is a factor. This conclusion I have explained here. Now this is applying at this place. Now one thing observe. Your px is x cube plus 1 and the factor by which, not the factor but the expression you are dividing by x plus 1. Now put it equal to 0. For the sake of obtaining the value x, then you will get x is equal to minus 1. By which expression you are going to divide the given polynomial, the expression would be made equal to 0 and you will obtain the value of x equal to 0. Now you simply calculate p minus 1 as in the previous exercise. When you will calculate p minus 1, what you will get? When you will calculate, means substitute the value of x is equal to minus 1 to the power 3 plus 1, you will get minus 1 plus 1, 0. Which 0 you are getting in the proper division method, the same 0 you are getting here. It means which work you have been doing in the previous exercise, simply you are doing here. But from where you will get the value of x to be substituted in the polynomial, that will be obtained by doing this step. By which expression the division is to be made. It means what will be your divisor, that will be made equal to 0 and you will obtain the value of the x which is to be substituted in the given polynomial. Now calculate simply. Whatever the value is coming, it is the remainder. If you are calculating PA, for the sake of simplicity, if you are dividing by this, then x plus 1 a is equal to 0. Similarly you will made it, and x is equal to minus a. So when minus a you will calculate, this will give you remainder. If remainder is 0, then it would be a factor. If remainder is not equal to 0, it will not be a factor. In this case, this is coming 0. It means remainder is coming 0. In this process, whole process, actually you are going to calculate the remainder. After the calculation, you will conclude that it is 0, remainder is 0. It means it is a factor of PA. If remainder is not 0, it's not a factor. Let us take example for the sake of understanding. Suppose I am dividing it by x plus 2. When you divide by x plus 2, then make it equal to 0, you will get x equal to minus 2. Now calculate minus 2, p minus 2. P minus 2 calculation means simply minus 2 to the power 3 plus 1. Minus, it will be minus 8 plus 1, getting minus 7. In this case, remainder is coming minus 7. That is not equal to 0. In this case, you will say x plus 1 is a factor of px. In this case, you will say x plus 2 is not a factor and remainder is minus 7. Without going through this proper division method, by this method or process, you can calculate the remainder. This is called the remainder theorem. In your exercise, you have been given certain questions and the expressions like this, x minus 2, x plus 1, whatever, and you will calculate that value which is to be substituted in px, and accordingly you will calculate the remainder. Remainder may come 0, may not come 0. If the question arises whether it is a factor, then you will observe whether it is 0 or not. So when it is coming 0, this becomes the remainder factor theorem. If remainder is not coming 0, you can say it is a remainder theorem. The processes of obtaining the remainder will be the same which I have explained. Now your exercise 2.3, your homework is exercise 2.3. There are 2-3 questions. You solve those. This is simple concept. Watch the video properly and solve the exercise. Thank you.